holds up the ramp, and in this case, this string right here. So if my system is this cart, there's a little mass on top of it, this string is effectively doing what friction was doing. Since I can measure how much mass is on the end of this string, I can figure out how much friction would be required. Like I can replace friction with this amount of weight. Does that make sense to everybody? Am I clear on that? Because so forces of friction acts along the end, so that's what this is doing. On the other hand, the support force of the ramp is also kind of mysterious because you can't see that either, and I'd like to be able to replace that. And one of the key questions that comes up is, which way is that support force acting? Because before, it always acted in what direction? Up. And I know we call it a perpendicular force, but up is perpendicular to something, right? So, and so I'm going to replace the perpendicular force by putting some over here. Now, I kind of went ahead of time and tried to calculate this and figure out what I needed. Well, I did some adjustments to get it right. And now I can get it to just replace it and to kind of make that, have you guys see that. I wanted to make sure that, get this on here? I think I need to make this. Okay. So if I have this right, and it's pretty close to being right, this string and that string should be perpendicular. Do they look perpendicular to each other?
Yeah.
So there are a couple of questions we can ask about this. If we think that the normal force should point up, that means I should have it about like this, right? If the normal force is, what's that? Straight up. If the normal force is straight up, well, if the normal force were straight up, what's the cart going to do?
You let it go.
If I let it go, what's it going to do?
It's going to go up.
It's going to move up, see? If I happen to draw it wrong and I have the normal force going down, what's it going to want to do? It's going to want to go that way, isn't it? So you see there's only one direction that that normal force can point in equilibrium and make this make sense, and that's this way. And then to kind of prove that we've actually done our job, what I can do is I can move the track out of the way. Well, we got caught. I should be able to slide the track. This mass is right in the way. Rats. I had my dramatic effect and I lost it. The string got nowhere.
Happens to me all the time.
No, you just have to suspense now because we're really waiting for that ramp to get out of the way.
Yes, I am. Oh, hold on. Let's try again. Put this in place here. I'm not going to move the ramp out. I got to keep that mass out of the way.
It's off.
How do we do? Okay, it wasn't perfect, but do we get the idea?
Yeah.
Okay. And so